Good morning, students. So today I am going to just revise the first chapter, Electrostatics 1. This is for the students, those who have joined a little later. Okay. So Electrostatics 1, ES 1. So you know that what is mean by electrostatics. So first let us go with what are electricity. Electricity means nothing but study of electron. This study can be classified into two categories. The study of electron can be classified into two categories. One is at rest and another one is electron at rest and another one is electron at motion. Electron at rest means that is called as electrostatics, and electron as motion means that is called as current electricity. Electrostatics is an important behavior of insulators. Why? In insulators only electron cannot be able to move. Okay, but current electricity is an important behavior of conductor, because in conductor the electrons can able to move. So we can classify this into two categories. One is electrostatics and another one is current electricity. Electrostatics is an important behavior of insulator. Current electricity is an important behavior of conductors. Sure. So, and there is a device which is used to detect the electrostatics is called as gold leaf electroscope. But there is a device which is used to test the current electricity is called as tester. Okay. So these are just the introduction about the electric charges. Now let us move on to the next topic, electrification. So what is meant by electrification? You might have learned the word what not electrification. So what is meant by electrification? Electrification means nothing but the process of transferring electron. Electrification nothing but what no? Transferring electron from one object to another object through rubbing or through friction or through conduction. Okay, that we can call as electrification. That we can call as electrification. And there are two laws for the electrification that you have learned. That two laws means first one is what? Like charges repel each other, unlike charges attract each other. Like charges repel each other, unlike charges attract each other. And the second one is charges always reside outside the conductor. For example, this you consider as a conductor. Okay, I am going to give charges to the given object. The charges always reside outside the conductor. It never go into. That is the important behavior of charges. So two things are like charges repel each other, unlike charges attract each other. And the second thing, charges never be inside. The charges always be outside the conductor. Okay, so these are the uses of conductor. Then here we are using a word polarity. So what is mean by polarity? Polarity is a property which helps us to differentiate the charges. Polarity is a property to helps us to differentiate. There are two types of charges. One is positive charge and another one is negative. So the classification can be done by using the word as polarity. So polarity means nothing but it is used to, it's a property used to differentiate or classify the charges, that we can call as polarity. Now, based on the polarity, the charges can be classified into three. One is neutral, then positive charge and negative charges. There are some substances they used to get positive charges, and there are some substances they used to get negative charges. Then don't forget the word as W, G, F. W means wool, G means glass, F means fur and dry hair, This all coming under positive charges. That means this all always not positive. They have the high tendency to lose electron. If electron loses from a neutral object, the object will become positive ion. Correct? No? That means they have the high tendency to lose electron. So that objects we can consider positive. Negative means nothing but rubber, plastic, ebonite, amber, okay, silk. So these are used to what not have the tendency of gain electrons. So they will what not called as the negative property or negative polarity substances. Understood now? So here you see that this you might have learnt in the small classes. You just put small papers over there and take a comb and rub the comb against your hair and just what not show the rod in front of the paper, the plastic scale in front of the papers gets what not attracted. The paper gets what not attracted. That is called as what not electrification. Okay, that is all due to the property of what not electrification. Understood, Namma? So these are about what not electrification. Now let us move on to the next one. The methods of charging. How do we charge an object? Okay. Charging. There are three different techniques. First one, conduction. Second one, induction. And the third one, what friction. So there are three different techniques. First one is what conduction. Second one is induction, and third one is what friction. There conduction. Conduction means there must be a physical contact. Induction, there is no physical contact. So conduction. What is meant by conduction? For example, let me take it mainly happened in the conductors, not in the insulators. Okay, so mainly happened in the conductor. Conductor means let me take two wires. One wire has 100 electron and let me take another wire. It has neutral. That means there is no excess charges. But here 100 excess electrons are there. Now I am going to and assume that both are similar. Similar means what nada? The area and length of the conductors are similar. Now I am going to just touch what nada? This with the first one. Now what will happen when you make touch here? The electrons will be transmitted. So now the 100 electron now this will become 50 and here 50 electron. They not always the electrons will be equally divided. If they are identical in nature, the electron will be. That means identical balls or identical rods means the charges will be equally divided. But it mainly depends on the area. It mainly depends on what area. If the area is more charges will be transmitted. If the area is less charges will be transmitted. So these are about what the one thing. So these we can call as what methods of charging. So there are three types of charging: conduction, induction, and what friction. Conduction, there must be a physical contact. Induction, there is no physical contact. Now let us move on to what induction. What is meant by induction? Sorry guys, let us continue. Okay, so now let us move on to the induction. In the induction, what we are going to do now? Let me take a metal bar. Induction, there is no physical contact, okay? And it is placed in a wooden stand. Okay, let me take a comb. The comb was not rubbed against the hair, and you know that comb is nothing but a plastic, so it gains electron, so it accrues negative charge. But the iron, it is a neutral. Let us take this is the iron bar. Okay, it's neutral. But when a comb is placed very close to the iron bar, you know that like charges repel, unlike charges attract. It is neutral. Neutral means what? It has same number of positive and negative charges. So all the positive will come this way and all the negative will be repelled to the other side. Correct na? All the positive charge will be coming one side, all the negative will be repelled on the other side. Let me take to the earth connection. That means the other terminal of the iron ball is connected to the ground, and you know that already we have learned about that earth connection. Ground is a good conductor of electricity. If here the negative charge will attract the positive, at the same time the negative will repel the negative, so all the electrons from the side will run through the metal wire and reaches the conductor. But this positive charge cannot able to move as they are attracted by the negative charges. Now let me remove the earth connection and remove the rod. Now what will happen? The positive will be equally distributed to the surface of the conductor. That means we can able to make a neutral charge conductor into a charged object, just placing a rod in front of it. So this we can call it as induction. Okay. See, the similar way we can able to charge induce charges on the two different metals. For example, let me take first one iron ball that is placed in a wooden stand, and let me take second iron ball that also placed on the wooden stand. Okay, let me take a negative charge now. Okay, the negative is placed over there, then you know that all the positive will be induced here, but all the negative will be induced in the next rod as they have physical contact here. Okay, here we don't need to use the earth connection, just separate the two balls, so and remove this thing. Then now what will happen? All the positive will come here and all the negative will come here. As again unlike charges attract each other. Now if you separated with a sufficient distance, all positive will be equally distributed among the, and all the negative will be equally distributed among the conductor. Understood? So this is the procedure to charge two different objects. Okay, so this is the procedure to charge two different objects. For induction, to find the induced charge, we are using the induced charge. For the induced charge, there is a formula. The induced charge is denoted by Qi. The I indicates the induced charge. The induced charge will be equal to minus Q into 1 minus 1 by K. The K is known as relative permeability. Relative permittivity. Okay. K is known as relative permittivity. For metals, the K is equal to infinity. So K infinity means 1 by infinity 0. So in the metal Qi is equal to minus Q. Why minus? If you are giving positive charge, negative only induce. Correct? If you are giving negative charge, positive will induce. That means if it is a conductor, if you are giving 100 charges means what? 100 charges will be. For example, if I am going to take a comb, the comb has now how much? 100 electrons. I am going to keep place in front of a iron chamber. Assume that is an iron chamber. So the iron will get 100 positive charge. Suppose if it is not a iron, if it is a anything like an insulator, means the Q will be the Q in the induced Q will be less than Q. That means if you are giving 100 charges, only less than 100 charges can be induced on the insulator. That means the K is for insulators. K will be greater than 1. So if the value is greater than 1, then what will happen? This Qi will be less than minus Q. The induced charge will be lesser than the charge which is given to the surface. Here Q is the charge given on the charged object and Qi is the charge induced on the next object. Understood? So this is the formula, okay, which is used to find out the amount of charge present in the given thing. Now we know that how that I already said you one thing. There is a device which is used to find the electrostatics. We can call it as electroscope. How the electroscope will be? There is a bell jar, okay, made by glass, and it has a simple rubber hole. Through the single hole there is a metal rod is running. This is the base of the metal rod. The two terminals of the metal rods are given to thin gold foils. Okay. Now, if I am going to bring a negatively charged particle very close to another, this base, and the negative will be transmitted to the conductor. But it's a conductor. Conductor, what will happen? The charge will be equally distributed. So this gold also will get negative. This gold also will get negative. Negative and negative, what will happen? Repel each other. So what will happen? It gets diverged this way. The measure of divergence gives the amount of electrostatic charge present over there. Understood or not? If it is diverged more, we can say that more charges are there. If it is diverged less, you can say that only what not a less amount of charges are present there. Okay, so it is the device which just able to measure or estimate. We cannot able to find out the correct estimates means what na, just nothing but it gives a rough measurement. The rough measurement can be calculated by using what not the gold leaf electroscope. Okay, so now let us move on to the next topic. What are the characteristics of the charges? There are three important characteristics. The first one, additive nature. Additive means what? Let us take Q is the net charge. The net charge can be taken as, so for example, this is an isolated system. There are Q2, Q3, Q4 and Q5. So if you want to find out the net charge in the system, that is Q net is equal to Q1 plus Q2 plus Q3 plus Q4 plus Q5. That means the net charge is nothing but the algebraic sum of all the charges. For example, let me take Q1 is equal to minus 5e, Q2 is equal to minus 10e, Q3 is equal to minus 15e, Q4 is equal to 20e and Q5 is equal to 10e. Now, what is the net charge? Minus 5e, minus 10e, minus 15e, plus 20e, plus 10e. So totally 10, 25, 30. Here also 30. The net charge will be equal to 0. The net charge of the system will be considered as 0. So there are three different additive. Second one is what? Additive. Additive means nothing but this algebraic. Algebraic means why we are using the word as algebraic. You have to consider as the negative and the positive. Okay, the algebraic sum of all the charges in the given system will be considered as 0. That we can consider as additive nature of the charges. Now let us move on to the next one, conservative. Conservative. Conservative, you know that there are two laws. One is conservation of mass and another one is conservation of energy. This you all learned. Conservation of energy you have learned in 11th standard mechanics. Energy never be created, energy never be destroyed. The net energy will be not a concept. Similarly, here we are going to study about and another one is conservation of mass that you might have studied in physical chemistry. The total mass in the reactant side always equal to the total mass in the product side. Correct? Similarly, here we are going to study about conservative of charges. That means charge never be created, charge never be destroyed. The net charge in the given system is always constant. The net charge in the given system is always constant. Then what is the meaning of that? When the universe formed, there are some charges. The same charges are still present in the universe. No other charges can be added, no other charges can be destroyed, but the charge can be transmitted from one object to another object, can be transformed or transmitted, but it cannot be created. We cannot create a charge, we cannot destroy the charge. That we can call as the conservative nature of charge. And the third one we can call it as quantization. So what is meant by quantization? Quantization of charge. Quantization of charge means what? Charge never be created. Quantization means you know that the net charge will be equal to the integral multiple of what? The charge E, and E, you know that E is equal to 1.6 into 10 power minus 19 coulomb. That means if n is equal to 0, the E value will be Q is equal to 0. If n is equal to 1, the Q value will be 1.6 into 10 power minus 19 coulomb. If n is equal to 2, the Q is equal to 3.2 into 10 power minus 19 coulomb. Now my question is that, see, if n is equal to 1, you will be getting 1.6 10 power minus 19 coulomb. If n is equal to 2, you will be getting 3.2 in 10 power minus 19 coulomb. Is 1.7 into 10 power minus 19 coulomb possible? Can be able to generate 1.7 10 power minus 19 coulomb? Not possible. Correct? Because half charge, quarter charge never exists. Charge always exists in the form of integral multiple. 1.6, the next one 3.2, the next one is 4.8 in 10 power minus 19 only. In between there is no charge. You know that in the hospitals you can able to find out two types of steps. One is the inclined plane to move the stretchers from one place to another place, and another one is steps. In the step we can able to keep, see, you can able to keep your leg here, and the next you can able to keep here only, the next you can able to keep here. In between here can able to keep? No. This is called as not a quantization. Quantization means a discrete value. Discrete means what? There are some values which is allotted already. They can have only that value. In between they cannot have any other value. That we can call as quantization. So quantization is a discrete. Inclined plane not like that. You can able to keep your leg anywhere, whatever place you can want. Okay. So this is called as continuous. Okay, this is called as discrete nature, this is called as continuous nature. But quantization indicates a discrete nature. Already there are some allotted values, okay, that electrons can have, or the net charge only can have that values. Understood not? Okay. And this quantization can be applicable only in microscopic level. Microscopic level means what? It can be applicable only if there are 100 electrons. Okay, if the electron is more than 100, we cannot able to apply the quantization, because quantization is invalid for what? Not a large number of electrons, because of two reasons. One is the value of the charge will be very less, 10 power minus 19 coulomb, and the second reason is the amount, that means the electron density is very high. For example, the tip of the pen the tip of the pen, not this pen, what we are having, the ballpoint pen, that has 10 power 6 electrons per, not how much? 10 power 6 electrons. The tip of the pen will have 10 power 6 electrons. So we cannot able to imagine. So the microscopic level only the quantization can be valid. In the macroscopic level we cannot able to not use the quantization. This we can call it as not a quantization of charge. Okay. So let us complete here. You just go through the notes. Already I have sent the notes. You just go through the notes. Okay. If you have any doubt, you can make a call, personal call. Okay. Thank you.